with twice cos A into sin B. Here A, B means A is greater than B in this case, will be equal to sin A plus B minus sin A minus B. This formula for A greater than B. This is for A greater than B. In that situation, cos A angle is greater. That means here cos 2x is there. Here it is sin x only. This angle is greater. Cos 2x on this. So we have to multiply this by 2. So 1.2 into x into 2 into, we write first cos 2x into sin x into dx. Now we can apply that formula. X into this is in bracket sin of A plus B means twice x plus x means 3x minus sin twice x minus x into dx. Okay, so this will give us 1.2 sin of integration x into first is sin 3x, this is okay, minus sin. Now this x into this multiplication will also be this square bracket x into this value also dx. Let me separate them. 1.2 x into sin x only. For difference of twice x minus x is only x. This is the value. Now let us integrate them by parts method. For this is by part, this is by parts also. Using the by parts method. Now using the by parts method. Okay, I'll write them simultaneously using by parts of BP method. We get, let me take this 1.2 out common. First integration of this x as it is, integration of sin 3x into dx minus sin ddx of x into integration of sin 3x into dx whole dx. This is the first one, minus sin. Again, let me write this in curly bracket. Now it will be x as it is, integration of sin into dx minus sin ddx of x into integration of sin x into dx whole dx. This is what we have applied. The VP method here also x into sin x. There are two functions, first function, second function, first function, second function. In both the functions, these two products we have applied the by parts method. Using by parts method, we get this. Now let me further resolve it. It will be minus sin, because this sin 3x integration is minus cos 3x upon 3. It will be minus x into cos 3x upon 3. Okay, this minus sign, it will be positive then. It will be x is 1 into cos 3x upon 3 into dx. This minus sign plus, because sin 3x integration is minus cos 3x upon 3. Okay, now this is minus sign here. Minus sign. Sinus integration is minus cos x, this must be plus. First is x into cos x. Here minus already plus. But from this it will be minus sign. Let me write here sin of integration 1 into minus cos x into dx. Okay, now 1.2 is throughout common. Will give us minus x upon 3 into cos of 3x plus sin. Now it will be cos 3x upon 3 again. It will be cos 3x integration will be sin 3x. For integration sin is there. It will be 1.9 sin 3x. I could take 1.3 common, then integration sin cos 3x dx. But integration of cos 3x is sin 3x upon 3 positive. 3 into 3, 9, and sin 3x will be there. Integration of cos 3x is this. Sin 3x upon 3, 3 is already there, so it is 9. Plus sin, this is now x into cos of x. Okay, now this is minus sign already. Let me write cos x into dx. Further integration, only one part is left over. So 1.2 minus x upon 3 into cos 3x plus 1.9 into sin 3x plus x into cos x. It will be minus sin x only positive. I mean not positive, but integration will be positive. Cos x means sin x only. This is cos x. So this is sin x plus constant of integration. Okay. So anything common? No, nothing is common. We can write only this way. So final answer, let me write here. The final answer of this is this one. Let me write here. Final answer is 1.2. Or let me separate them, or just write positive term first. X sin x, x cos x, x cos x minus sin x, then minus x upon 3 into cos 3x plus 1.9 into sin 3x. Can we internalize this plus constant of integration? These two steps we have taken first. This is answer. Okay, so this is question number 5th we have done. Now question number 5th is solved. Now let us talk about 6th question. What is question 6? Now question number 6th. What is the question number 6th here? Okay, so let us take question number 6th. Now it says sine of under root x. No problem. It says sine of integration. Sine of under root x into dx. Now, if I substitute under root x equal to something, okay, but here 1 is to be taken with multiplication. Okay, if I divide it by under root x and multiply by under root x, no change. Then let us take under root x equal to t. Okay, so that will be better. Let me multiply this by under root x, and this is sine under root x upon under root dividing and multiplying by under root x, no change. Now let us take let under root x equal to t. Therefore, this is actually called half IB in t, or now differentiating it with respect to t, we get here it will be half, actually for minus half into dx upon dt equal to 1 over 1 upon root x into dx equal to dt upon dt into 2 or 2 dt, 2 into dt, cross multiplication. That means 1 upon under root x into dx equal to 2 dt. This t is right here, t under root x is t, with sine of t into dt upon 2 into dt. This 2 we have taken out of integration sign twice into, let me write again, sin t into dt. Now it's okay. This is after substitution. What is 1 upon under root x? This one into dx equal to 2 dt. That is there. And under root x equal to t, which we have taken. Okay, sorry. So this is, now it can be integrated by parts method. Using by parts method or BP method, the integration of it will be is equal to constant common as it is, t first function as it is, integration of sin t into dt minus sin ddt in this case of t, integration of sin t into dt whole dt. Okay, now let us further integrate this. So this is t into, now sin t integration is minus cos t, cos t. Minus plus it will be t is 1 into cos t into dt. Once more integration of this, it will be minus 2 into t into cos t plus 2 into, now integration of cos t is sin t. So let me write cos t in a proper, now it can be integrated. It will be minus 2 into t into cos t plus 2 into sin t is constant of integration. Now substituting the value of t for the under root x. This is minus 2 under root x into cos under root x plus 2 into sin under root x plus constant of integration. This is the answer here because t is equal to square root x. Okay, so that is the answer here. This is the answer. And let us talk about question number 7 now. So question number 7 now. What is the question number 7? Let us talk about question number 7. Okay, so question number 7 here, which is sin x into log of cos x. Okay. This is sign of integration, sin x into log of cos x into dx. Okay, or it can be written as log of cos x into sin x into dx. Okay, so let cos x equal to t. Now differentiating it with respect to t, we get minus sin x into dx equal to, let me write directly, or sin x into dx equal to minus dt, because differentiation of cos x is minus sin x into dx equal to dt, or sin x dx equal to minus dt. So substituting this value, it is log of t here into dt minus dt, minus sin can be taken out. Now it is the only function log t. We will take 1 in multiplication of this, okay, which will be taken as the second function, because L logarithm function is considered as first function. Now 1 is not inverse function. 1 can be taken as LH function or maybe polynomial. That way, but 1 is x raised power 0, that means 1. Okay, so here we can multiply by 1. It is minus sin log of t into 1 into dt. Using bypass method. Okay, now using BP method and taking 1 as second function. 1 as second function. What it will be? Integration of this will be minus sin log of t as it is. Integration of 1 into dt minus sin is minus 1 plus sin of ddt of log t into sin of integration 1 into dt whole dt. This is equal to minus log of t. 1 t on dt means into t plus sin. Now log t is 1 on t, and this is t. 1 dt is t into dt. So t cancel out. Only 1 dt again has come. Minus log of t into t. Let me write it here. T into this t into log of t. T into log of t. This is plus sign. This is 1 into dt, that means t only, plus constant of integration. Now substitute the value of t is cos of x. Cos of x into log of cos of x plus cos of x is constant of integration. Because cos x we have considered as t. So first is negative, this is minus cos x log cos x, or we can take here cos x common. It will be 1 minus log of cos x plus constant of integration. This is the answer here. Another answer is cos x we have taken common. In bracket it is 1 minus log cos x. Okay, this is the final answer. Question number 7 now is completed. Now let us talk about 8th question. Now question number 8th, let's talk about question number 8th here. Okay, this is sine of integration x into sine inverse x upon under root 1 minus x square. Let us consider sine inverse x equal to. This is substitution method. Let sine inverse x equal to t, no problem, or it means x equal to. First let me differentiate it. Differentiating it with respect to t, we get 1 upon under root 1 minus x square into dx upon dt is equal to 1. So this is dx upon under root 1 minus x square is equal to, this is equal to dt. Alright, but here from this one x equal to what? This implies that x equal to sine t. From this x equal to sine t taken to that side, it will be sine t. X in place of x we can substitute as sine t, and this is sine inverse x is also t. This is t into sine t. T into sine t. This is t sine inverse x, and x is sine t into dt. Only got this 1 upon, I'm sorry, here dx is also. So dx upon under root 1 minus x square equal to dt. Substituting this value, we have now obtained t into sine t, which is to be integrated in by bypass method, because they are in multiplication. In case of two functions are in multiplication or in product form, we apply the bypass method. This is, let us talk about using now bypass method. Using BP method, we get, it will be t constant, sorry, t as it is the first one, this is the first one, second function, algebraic function, trigonometric function, algebraic function, trigonometric function. Okay, so integration of sine t here into dt minus sine ddt of t, integrating with respect to t here, integration of sine t into dt whole dt. Therefore integration between sine t is minus cos t, so it is minus t into cos t. Minus sine it is also positive, because sine t will be minus cos t. Minus sine will be positive plus sine. If t is 1 into cos t into dt. Now why this minus sign has become plus? Because this sine t, integration of sine t is minus cos t, minus into minus is plus. Now cos t is to be integrated minus t into, this is cos of t plus sine cos t, integration of cos t, let me get dt. This will be minus t into cos t plus, this is nothing but sine t plus constant of integration. Cos t integration is positive sine t plus sine t. Okay, plus constant of integration. Now substitute value of t, where t is sine inverse x. Okay, so this is minus sine inverse x into cos of sine inverse x, value of t. Okay, plus sine of sine inverse x plus constant of integration of t is sine inverse x. It will be minus sine inverse x into cos of sine inverse x plus this sine cancel out, this x plus constant of integration. So sine into sine inverse x by sine inverse x into sine is equal to x, the angle itself. It is angle the x only. This is the answer here. Final question. So 8th question is solved. Now let's talk about the next question. Now 9th question. Let's talk. Question number 9. Question number 9. Let's talk about it. 9th question is sign of integration. It is log of x upon x square or x only x into dx. Again, let us take log x equal to, let log of x equal to t. Differentiating it with respect to t. We get, this is 1 upon x into dx, will be write directly. Dx upon dt, we have taken to the side, that will be 1 into dt, that means dt. So 1 upon x into dx dt, we can substitute this as log of t into dt. Now log t is again single function. We have to multiply it by 1. We can write it as sign of integration log of t into 1 into dt. Okay. Now using BP method. Now using BP method, we get, it will be now log of t as it is, first function, integration of 1 into dt minus sign ddt of log t into integration of 1 into dt whole dt. This is equal to log of t into 1 integration is t. Let me write t first. Minus sign. Now differentiation of log t is 1 upon t. 1 dt is t into t, because ddt of 1 is t into dt. Dt cancel out. This is t log of t minus sign is 1 into dt. Integration will be t plus constant of integration. This is 1 into dt, alright? Dt cancel out, 1 into dt, 1 integration is t. So finally substitute the value. This is log x. T in place of t, we can substitute log x. The first is log x into log of x minus sign log of x is constant of integration equal to 0. Sorry, this is the final answer. Constant of integration is there, but this is minus log x, that means t, and this is log t means log of log x. It's t log x. This is the answer. Question number 9, we have done. But let's talk about 10th question. Question number 10. What does it say? Now question number 10. Okay. Question number 10 is that one. Okay. Sign of integration. This is e raised to power x within bracket 1 plus sin x upon 1 plus cos x. Okay, so 1 plus cos x. Okay, now we can substitute here. Now in the denominator we have 1 plus cos x, no problem. Then we can do. Let me change it. 1 plus sin x in the numerator. Okay, if I substitute, no problem. 1 plus cos x equal to that, and it can be separated. But that sin x is okay. Let me write here. So this is the dx. This is question number e raised to power x. Now 1 plus sin x can be written as the sin square x by 2 in place of 1 cos square x by 2 plus 2 sin x by 2 into cos x by 2. This is the value of sin x divided by 1 plus cos x, 1 plus cos 2x is cos square x by 2 into dx. So in the numerator, we have what can be separated. Alright, then there are 3 parts, but if we write here cos x plus sin x whole square, that is not going to solve the problem. So let us take divide this whole by cos 2 cos square x by 2. So that will be sin of integration e raised to power x into, this is sin square x upon cos square x, that is tan square x by 2 1.2 is here, that we have taken out into dx. If I do this in this way, and this one, the second one will be only 1.2. Sin of this ex will be left over, and the ex into this cos square cancel out ex plus sin of 1.2 to cancel out. Okay, this 2 to cancel out. So integration of sin ex into this 1 cos x cancel out. Okay, so sin x upon cos x is only tan x by 2 into dx. In this way, we can change them into 3 parts. Now it can be, but this can be substituted here. Trigonometric transformation. It can be written as, let me write 1.2 sin of integration at ex into tan square x by 2 is secant square x by 2 minus 1 into dx. Plus this is 1.2 integration of ex is ex only. Let us integrate this. Plus here it is by parts method. Now if I write, okay, sin x by 2, it can be written as sin of integration ex into sin x by 2 upon cos x by 2. Okay, so this is tan x by 2. Okay, tan x by 2 could be written as sin x by 2 upon this. But that is, let me talk about. And if I write it as sin x by 2 upon cos x by 2 into dx. So that we will do in that way. Okay. Now let us talk about this one. This will be cancelled out by this. Okay. So it is 1.2 into ex into secant square x by 2 into dx minus sin half sin of integration. This is ex into dx, and this, I think these two will be cancelled out. I have already, let me write it as ex into dx. These two are cancelled out. This one and this one, and from this minus half ex into dx. So these two are cancelled out. Only these 2 parts are left over. Sin x by 2. This is, okay, it may be, let me write here tan x by 2. It may be cancelled out. I'm not solving it. Only write it as, it is tan x by 2 into dx. Only, okay, let me keep it as it is. It is tan x by 2 into dx. Okay. So now let me integrate this one. Integration of this by parts method. It will be by parts method, or using by parts method. This is to be integrated as logarithm function is second function. This is the first function. Trigonometric function is the first function, and exponential function is the second function. So maybe it could not be transformed to tan x secant square x by 2, because we are not to integrate this. In case of that, I think this question is to be done in a different method, different way. Is there anything okay else which can be taken as 1.2 cos square x by 2? This is okay. And then second is sin x upon be taken as cos x, okay. That could be taken as t. So then x equal to t minus 1 into cos x, or x equal to sin minus x by 2. So it means e to the power x will also be cancelled out then. Okay, I'll take this later. In the end, I'll talk about this question because it may include something, or maybe this will be cancelled out, or this to be integrated now. For differentiation of, let me integrate that. Okay, then it can be cancelled out. Let me talk about this one. This are keeping same. Okay, let me integrate this. It will be have 1.2. I have kept this as because no need of this changing. Second square x by 2 into dx as it is. Now let me integrate this function. It will be by parts, using by parts method. So this is to be integrated by using by parts method. So it will be 10x by 2 as it is, first function, into integration of e raised over x into dx minus sign of integration. Now ddx of 10x by 2, okay, into integration of e raised over x into dx whole dx. Now this will be cancelled out, okay. Plus sign, this is 10x by 2 into e raised over x, integration of e raised over x. Now this value is, what is integration of 10x by 2? Second square x by 2. It will be sign of integration second square x by 2 into 1.2, because this 1.2 is 1.2 will come here. This is e raised power x only into dx. This function and this function are cancelled out. In this way, these kind of questions are known as that when the integration of that function is also given there, it will now cancel out. Second square x by 2 into dx. This and this cancel out. Answer is only this much. This is e raised power x into 10x by 2 plus constant of integration we can write here. Okay, this is done. No need of solving it in the end. This is the final answer. I understand this. There are certain times the questions are given in which the integration of that function is also given. That function will be cancelled out. Finally,